So to get into the second portion of our lecture, or lecture 2 for chapter 1, I want to go in a little bit in more depth to discuss the terminology used in your chapter. That's really terminology we're going to use throughout the course. So in terms of research questions, and for those of you who've looked at the syllabus, you'll see that the final project discusses either a research question or questions that you would like to have answered, or a hypothesis. So research questions are those questions that researchers really seek to answer by collecting either data or doing their own observations, their own interviews. And they really communicate the variables and the population, or the entire group that you want to look at. So an example would be in hospitalized children, does music reduce stress? So the population would be hospitalized children. Now, we had mentioned in lecture 1 that a really good statistical analysis is generalizable in terms of you can really make inferences from your smaller sample to the general population. So in looking at in-hospitalized children, while you may be looking at your study through 40, 50, potentially 100 hospitalized children, the goal is to generalize that to all hospitalized children in terms of a population. Does music, the independent variable, reduce stress, the dependent variable? So remember, in the relationship, you can always think of the independent variable. Remember in lecture 1 where that line, the arrow is drawn to the dependent variable. So does music influence, or in this case, reduce stress? How is that relationship? How does that work? I wanted to take the abstract from your reading, and in the class it's titled Article for Homework. And this, what you see on your screen, is basically the abstract of the article. So that first initial paragraph in italics. And in the abstract, if some of you have looked at the homework, I'm asking you some general information about the article itself. And sometimes students will get really excited in the abstract and say, well, everything I need really is right here. And I'm going to highlight to you some important things that we can see in the abstract, but also some things that we'll be missing. So the first thing I wanted to point out here, and that I have here in green, is we're really identifying what data are we looking at. So the new immigrant survey data is a large data set, is what we would call it. And it's where surveys have been given to, and in specifically the Hispanic population. So these, the population we're looking at are Hispanic immigrants. And this survey, just kind of going back here, the new immigrant survey was a survey given specifically to the Hispanic immigrants within this sample. So obviously you can't pull the entire population in the United States. They gathered from a smaller subset of that. They identify here that there were 3 important findings. Now, I asked specifically, what is the research question, or what are they trying to find out? Specifically in this abstract, they don't give you what the research question is, they give you the findings. So what they identify here is, first, individuals who have been in the United States longer report a greater degree of dietary change. So this is really important. We see that among Hispanic immigrants, so that specific sample of the population, their diets definitely change once they've been in the United States for a longer period of time. Now that's a really, statistically, that's a significant finding because it definitely potentially has policy implications for, how are immigrants coming into our country acclimated to food? How are things different from in our culture to other cultures? The second finding, and I parsed this out a couple ways, so bear with me, but the second, it says, after controlling for behavioral characteristics. So an example of a behavioral characteristics, and I don't know from this, it'll state in your article specifically, and you can look at that. But a behavioral characteristic of why you may have a different eating habit is considered, and that's really important. If you have people who may have eating disorders, you want to identify that because they would look differently than people in a normal kind of sample of the population. So controlling for that, and when ever you see an article that says after controlling for, that means that they've taken into consideration those people and pre-existing diet-related conditions. So if they've had blood pressure or diabetes prior to, more dramatic levels of change in diet are associated with higher measures of body mass index. So for those people who are heavier and have higher BMIs, they experience the most dramatic level of change. So chances are, and you can definitely find that out by reading the article a little bit more, is that their health is probably negatively impacted by coming here to the United States. And part of the second finding is that based on the respondents' comparisons, so respondents in this specific instance are the Hispanic immigrants that did take the survey. So based on the respondents' comparisons of their current health to their health just prior to their most recent trip to the United States, change in diet as a result of immigrating to the United States is positively correlated with both better health and worse health. So what this means in terms of a positive correlation is they find that one thing definitely impacts the other. And some people look at positively or negatively. Basically, what a positive association means is that there are findings to show that the independent variable does impact the dependent variable. That's a positive correlation. And it with both better and worse health outcomes is really interesting. So who are those who have better health and who has worse health? So then the last portion of that is for individuals that had greater changes in their diets, those with the worst health had been in the United States for longer and are more likely to report the use of English at work, which means that they've been in the United States and they're really acculturated. So someone could really argue that although they were raised in another country, because they've been in the United States for so long, and an indication of really being acclimated to the United States is using that primary language in the work or home, that, again, it says right here, are more likely to report the use of English at work than those reporting better health. Factors that indicate acculturation and exposure to the broader U.S. society. So this negative impact and those with worse health have been in the United States for a long time. So unfortunately, our immigrants that are coming into the United States are being negatively impacted in terms of their health by being in our environment. So I wanted to show you that. I think I've probably answered 2 or 3 of your questions for the homework, but that's okay. I want this as kind of a stepping stone to kind of get you to understand how to look at and parse out what some of these findings and what some of the jargon in some of these articles mean. Because once you get reading them, it will seem like it's really hard to wrap your brain around the language of what they're using. But part of kind of being in this system of higher education and working alongside nurses that are doing presentations and healthcare professionals talking about evidence-based practices is really knowing some of the language. And once you know it and once you've looked at a couple of these, it will come much easier. And I know probably pulling up the article for the first time might have been scary and intimidating, but by the time we've looked at a couple of these and you can pick out the main points, you'll be able to make sense of it a little bit more. I promise. There are still some articles that I'll come across that seem like the author used a thesaurus probably more than they should have. But once you can parse out the pieces that are really important to look at, it becomes much easier. So in terms of variables, once you have a study or a research question, variables need to be defined by 2 ways. So I'm going to talk about the variable of stress. So a conceptual definition is basically the theoretical meaning of the underlying concept. So let's think about stress. What does stress mean? For a literature review in any of these journal articles, most of them will have literature that has been done discussing what is stress or what do we mean by better health outcomes. That in itself will be kind of the conceptualization of what we mean by stress. What does that mean? The operational definition is how are we going to measure stress? Now, conceptually, that we know what stress is, how are we going to operationally define or measure stress? Are we going to operationally define stress as heart rate, blood pressure, maybe a combination of a couple of things? That's the big difference between a conceptual definition and an operational definition. And again, if any of you, as you're listening to the lecture and maybe backing it up to really wrap your head around it, if you really feel like I need to talk to Amy in person to really have her go over this with me, please just call or email. I'm definitely better with email, but just, let me know and we can set up a time to meet and go over them in person. There are also two different kinds of variables in terms of discrete or a continuous variable, and these just have different qualities in terms of the measurement potential. So let's dive into this a little bit. A discrete variable are categories that are indivisible. So with with a finite number of values between 2 points. So the examples that I put up here are number of siblings. You can have 0 number of siblings, 1, 2. You can't have 1.2 siblings. You either have 1 sibling or 2. Number of hospital beds, also in a hospital. You can't really have 129.03 hospital beds. Excuse me, that's not possible. And so statistical purposes, that would be looked at. Both of these variables specifically would be called discrete. So continuous variables can, in theory, assume an infinite number of values between 2 points. So if I ask you today, what is the time elapsed since your birth? Now, I should not have put 55.0359 because I am not 55 years old. I'm like 20 plus years younger than that. So, but again, that just kind of shows you that if you asked very genuinely and kind of allowed for that expansion of decimal points, that could really be an infinite number in terms of the actual time elapsed since your birth. So with measurement, we're going to look at different modalities of measurement in statistics. And again, these are also terms we'll be using throughout the semester, but this involves assigning numbers to qualities of people or objects to designate the quantity of the attribute. So let's get into this to explain a little bit more about that. We're going to look at 4 primary levels of measurement. These are the 4 types of measurement rules that affect the kind of statistical analysis that's appropriate. So depending on through the semester towards the end when we talk about multiple regression, it's really important to know the level of measurement of your independent variable to know what type of regression is important. And again, that will make absolutely no sense to you right now, and it shouldn't because we haven't learned about regressions. But just know that having a nominal independent variable is much different than having an ordered or an ordinal independent variable. So a nominal measurement, just to kind of give you an example, is that if you were to have a questionnaire, just a regular survey, let's say you wanted to ask 5 questions of your class, but you wanted to collect some attributes so that you could compare maybe males and females, age. If you were to have the members of your class identify their sex as either male or female, once you've collected that, you would assign a number to that. So you would be able to code your data according to if someone responded as a male or someone responded as a female. So in this example, I just kind of threw out some pictures of a nominal measurement is the lowest form of measurement, and numbers are only used as a category, just to kind of give a name numerically to your variable. So again, sex coded with 2 arbitrary numbers, 0 for males, 1 for females. And that could be switched based on, it doesn't matter what the coding looks like. In the first example, if you just look on the far left, I have my male and female, and we've coded that as 0 and 1. That works. You can do that. Towards the other side, or the middle side, the middle set, maybe you want to have females be 0 and males be 1. Maybe you don't want to use 0 and 1. Maybe you want males to be 2 and females to be 4. It doesn't really matter what number you assign. It's just so that it's consistent. So again, looking all the way to the left of 2 and 4, it doesn't matter if you use 2 and 4, 2 for males, 4 for females, as long as it's consistent. So everyone that's taken your survey, if they're a male, they'll always be a number 2. And if they're a female, they'll always be a number 4. It's just important that you know that it doesn't really matter. Those numbers are just an attribute. It's not placing, quantitative meaning. It's just assigning a number to a characteristic. So ordinal measurements use numbers to designate an order. And sometimes we'll see an ordinal measurement be like a Likert scale. Like, do you agree with this? Strongly disagree, agree, strongly agree. This conveys some information about the amount, but it doesn't indicate distance between the values. So the example here, I had mentioned this in lecture 1, degree of pain. If you have 1 is none, 2 is you have some pain, and 3 is a lot. The distances may not be that equal. Going from some pain to a lot of pain is really, really difficult to parse that out. It's also, if you've ever taken a survey that says strongly disagree, disagree, agree. So for someone who really strongly disagrees with something, that's not much difference than someone who agrees. That's like 2 points worth. So that's where the distances really aren't equal and they're not known. So to make an average of this kind of a measurement doesn't really make sense. To say, well, the average degree of pain was 2.3. Well, that doesn't really tell us a lot about those who are ones, who are truly didn't feel any pain. Maybe you had somebody who wrote in a number of 10 and that was an option and they didn't throw out that number. They considered it and that really threw off the scale. So again, this is with ordinal measures, you're really just trying to look at the information in terms of the scale. What does that mean? Interval measurement also uses numbers to designate ordering on an attribute, but information is conveyed about it in terms of distances are actually assumed to be equal, and averages can be computed. So an example is temperature. We see this a lot on the news. What's the average temperature for this day? What was the high and low in terms of a record? So the difference between 70 and 75 degrees is the same as the difference between 75 and 80 degrees. You can say, well, we were 10 degrees lower at this point a year ago. That essentially does have the same meaning in the winter as it does in the summer. It means that 10 years ago, there was a significantly lower, it was cooler. So it's really important just to know that averages are definitely used for interval measurements. Ratio measurement is the last level of measurement that we'll talk about. And in ratio measurement, you don't see this nearly as often in some journal publications. Where you do see ratio measurement is definitely in nursing and medical journals that will look at medication dose, either in number of milligrams, number of pills. There is a real 0 and a rational 0 in terms of milligrams, for example. You could have 0.05 or 0.5, and that has a meaning. Averages can definitely be computed, and those numbers are used to designate some kind of ordering. And again, these levels of measurement will make more sense when we're able to see some examples of this. So measurement level of comparison, at each of the levels, there is more information and more analytic flexibility. So if you start with ratio measures, you can collapse that information into lower level measurings, but the reverse is not true. So if you have higher level scales, those are usually preferred. And what we mean by a higher level scale